Now, last video we talked on conversion from Cartesian form to polar form, and likewise from polar form to Cartesian form. Now, in this video we have a question on how to perform addition and subtraction of polar form of complex number. Okay, so the first thing to do in this format is first convert it to Cartesian format. Okay, because addition and subtraction cannot be done on polar form. However, multiplication and division is possible, and we will get to there. We'll get there. We'll get there. Now, let's take a look at this question. We are given modulo p to be equals to 2 arguments 30, and q to be 3 arguments 90, and r to be 4 arguments minus 60 degrees. Now, the first thing to do is to first convert each and every one of them to Cartesian format, right? So we recall that z is equals to r cos theta plus I sine theta. Now we're given p to be equal to 2 arguments 30 degrees, where r 2 is equals to r and our theta is equals to 30. So therefore wherever we see r, we put 2 cos 30 degrees plus I sine 30 degrees. So this will give us 2 into 0.8660 cos 30 degrees is that, and plus I 0.5 sine 30 is 0.5. So this will give us 1.732 plus I. Now this is P. We do the same thing for Q. Q is 3 arguments 90 degrees. So this will give us 3 because our R is 3. And wherever we see theta, we put 90 degrees. Okay, so cos 90 degrees is 0 and sine 90 degrees is 1. So this will give us 0 plus 3i, which is equals to 3i. So this is Q. And also we have R, which is 4 arguments minus 60 degrees. So this will be 4 into cos minus 60 degrees plus I sine minus 60 degrees. And if we press our calculator, we have that our cos minus 60 degrees is 0.5 plus I, and our sine minus 60 degrees is 0.8660. Now, in essence, this is going to give us 2. Okay, sine minus this. This will give us 2 minus, because 4 times 0.5 is 2, minus 3.464 I. Now, after this is done, we can now bring them together. That P is equals to 1.732 plus I. Q is equals to 3I. And R is equals to 2 minus 3.464 I. Then we can go to the first question. The first question says P plus Q plus R. P plus Q plus R. Now we can perform the algebraic sum of the 3 complex numbers. So this will be equals to 1.732 plus I plus 3I plus 2 minus 3.464 I. Thereafter, we collect like terms after we open the brackets. So opening the brackets individually, we have this. Then let's collect the times, like terms. So we collect common terms first, the real terms, 2, and then the imaginary terms in these. So subtracting further, we have 3.732 plus 0.536I. And since our first question was given in polar form, it is now essential that we have to convert back, okay, convert back to polar form. When we convert back, how do we convert back to polar form? We go back to our two previous videos, or our last video. Then the first thing to do is to first draw the Hagan diagram. We can see that this has a positive real number and as well as a positive imaginary number. So positive real, okay, because the real axis is significant, is corresponding to the x-axis, and the imaginary axis is corresponding to the y-axis. So thereafter, we can assume that this is 3.732 and this is 0.536. So drawing it further, we now have this. So as we do before, we bring out the triangle that we are dealing with, the right angle triangle that we are dealing with. There we can draw angle theta. The distance here is 0.536 and this is 3.732. And you have to calculate the modulus. So the first thing is calculate the modulus. According to Pythagoras theorem, our modulus will be square root of a squared plus b squared. So r is equals to square root of 3.732 squared plus 0.536 squared, which will give us approximately 3.77. Now the next thing is to calculate our theta. Okay. Now if we look at this, the side facing angle theta is called opposite, and the side facing here is called adjacent. And we recall that tan theta is equals to opposite over adjacent. Opposite is equal to 0.536 and our adjacent is 3.732, which will be equal to 0.536 divided by 3.732. It is depending on 0.1436. Now we can evaluate our theta to be tan 0.1436, which is equivalent to 8.173 degrees. Now, if you notice this, our work is in the first quadrant, and in the first quadrant, our argument z is equals to theta, right? Our argument z is equals to theta, and we recall that if z is equals to a plus bi, our z can also be written as r into cos theta plus I sin theta, which can also be significantly written as r argument theta. Okay, so where the theta here is equals to argument of z. Okay, so in short, we can now write our final answer. Our final answer of P, okay, PQR, P plus Q plus R which is equal to 2 minus 3.464i is equal, okay, when we evaluated this, we saw that our r is equal to 3.77 and our theta, okay, or argument z, okay, our argument z is equal to 8.173 degrees. We can write that this is also equal to 3.77 into cos 8.173 degrees plus I sine 8.173, or best way to leave it should be in the format of the question, and the question is given in this format. Okay, so we have our R to be 3.77 and the argument, the theta, as 8.173 degrees. So this is our answer. Now in the second question, we are asked to evaluate P minus Q minus R, and after conversion, realize that our P is equal to 1.732 plus I, our Q is 3I, and our R is 2 minus 3.464I. Now, with this done, we can evaluate P minus Q minus R. So we substitute our P, Q, and R. We have 1.732 plus I minus 3I minus 2 minus 3.464I. Now we open the bracket up with negative, so this will give us 1.732 plus I minus 3I minus 2 plus 3.464I. Then we bring in like times, so that will give us 1.732 minus 2 plus I minus 3I plus 3.464I. Now we have to evaluate 1.732 minus 2. This will give us minus 0.268 and 1.464I. Now, having done this, we are now have to calculate, evaluate, or convert this Cartesian form of complex number into polar form. The first thing, as usual, is to draw the Argand diagram. It's very important we draw the Argand diagram so that we will know the quadrants at which we are dealing with. Now we'll see that this has positive real number and negative and positive imaginary number. So to draw the Argand diagram, we are going to be dealing with the positive imaginary number and the negative real number. The negative real number stands at minus 0.268 and the positive imaginary number stands at 1.464. Thereafter, and afterwards we can bring out the triangle we are dealing with. Okay, so let's focus on the triangle now. So we have this to be 0.268 and this to be 1.464. and angle theta with r. We calculate our modulus, should be square root of a squared plus b squared according to Pythagoras. So this will be square root of 1.464 squared plus 0.268 squared. Evaluating this, we have it to be 1.488. And then after we have to calculate our theta, recall that tan theta is equals to opposite over adjacent. Now going further, the side facing the angle theta is called the opposite, and the other side is called the adjacent. So with this done, our opposite is 1.464 and our adjacent is 0.268. So our theta will be equal, or tan theta will be equals to 1.464 divided by 0.268. This will give us 5.463, and our theta will then be 5.463, and theta will be equal to 79.63 degrees. Now, having been able to evaluate theta, we will now have to look at the quadrant we are dealing with. Okay, we can see here that we are in the second quadrant. Okay, and this is theta. So going back to our understanding in our previous videos, if this is theta, then our argument of theta, we start counting from here, is going to be 180 degrees minus theta. Therefore, our argument z will be 180 minus 79.63 degrees, which will give us 100.37 degrees. Now, we know our R to be equals to 1.488. We know our argument theta, argument z, to be equals to 100.37 degrees. So therefore our conversion of this, that is minus 0.268 plus 1.464i, will be written in terms of in the format of this. Okay, so our R is 1.488, argument 100.37 degrees. So calculate in complex numbers. Okay, to add and subtract of complex number in polar form, it is very important that we understand this theorem. Okay, that when we are adding and subtracting, we would have to convert back to Cartesian format, and from the Cartesian form we can now perform the arithmetic addition and subtraction operation, and then we convert back into the polar form. And now in our next video we'll be considering multiplication and division of complex number in polar form. Okay, in polar form, and thereafter we go into the exponential form of complex number.